Yeah, let us welcome in next lecture of MAT-201, that is integral calculus. So in this lecture we will see Gauss divergence theorem, that is reduction of volume to surface integral. The statement of Gauss divergence theorem is that if f is continuously differentiable vector point function and S is a closed surface enclosing a region P, then surface integral f bar dot n cap ds is equal to volume integral, that is volume integral over region V of divergence of f dv. So here n cap is the unit outward drawn normal vector. So Gauss divergence theorem gives us a transformation of surface integral to volume integral, and volume integral is given in terms of divergence of f, and therefore this theorem is called divergence theorem, Gauss divergence theorem. So in terms of Cartesian coordinates, the Gauss divergence theorem can be stated as below. The surface integral means it is double integral f1 divided dz plus f2 dz dx plus f3 dx dy will be equal to volume integral, that is triple integral over region V, that is dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z and dx with dy dz. So this is the Cartesian form of Gauss divergence theorem. So next we will see examples on Gauss divergence theorem. So first example, if suppose OA bar is AI bar, OB bar is equal to AJ bar, OC bar is equal to suppose AK bar. Form three coterminous edges of a cube and yes, denote the surface of the cube. Question is that evaluate the surface integral over yes x cube minus yz I bar minus 2x square y j bar plus 2k bar dot n cap ds by expressing it as volume integral. So you have to find the surface integral. To find the surface integral, so directly you are not finding a surface integral or a double integral, you are using Gauss divergence theorem and you are finding volume integral, and so that it gives us a surface integral. So let's suppose you have bar, that is x cube minus yz I bar minus 2x square y j bar plus 2k bar. So let us find the divergence of f bar, because we are using your Gauss divergence theorem and we require divergence of f bar. So let's find divergence of f bar. So using definition of divergence of f bar, so it will be dou of x cube minus yz dou x plus dou of minus 2x square y dou y. So we are differentiating f1 with respect to x, f2 with respect to y, and then f3 with respect to z. So that will give us divergence of f bar is equal to x square. So using Gauss divergence theorem, we have the surface integral f bar dot n cap ds equal to volume integral over region V of divergence of f dv. So already we have find the divergence of f. So let us put this, and dv, that will be dx dy dz. Yeah, just a minute. Yeah. So dv will be, that is dx dy dz. So it will be triple integral over region V of x square dx dy dz. So first we'll find the first integral, that is with respect to x of x square, that will be x cube upon 3, and after putting limits, so you'll find it as, yeah, a into, so first integral will be a, and second integral will be a, and third integral will be a cube upon 3. So resulting value of this integral will be a raised to 5 divided by 3. So this will be the, yeah, value of the surface integral. But to find the surface integral, so we find the volume integral, that is triple integral, using Gauss divergence theorem. So this is first example. Second example, so yeah, you have to show that the surface integral over surface S of x I bar plus dy j bar plus z k bar dA bar is equal to 4 by 3 pi a plus b plus c. So where S is the surface of the sphere, x square plus y square plus z square equal to 1. So basically, let's take, suppose f bar is equal to x I bar plus dy j bar plus c z k bar. So what is divergence of f bar? So it will be yeah, partial derivative of f1 with respect to x, f2 with respect to y, and f3 with respect to z. So it will be a plus b plus c. So my Gauss divergence theorem, the surface integral of f bar dot dA bar over surface S will be uh, yeah will be volume integral of divergence of f bar over region B. So here divergence of f bar is a plus b plus c. So you can take this outside of this integral because you are integrating with respect to v. And what is this integral of dv over v? So it will gives us volume v. And what is v? V is the volume of sphere x square plus y square plus z square equal to 1, which is the unit sphere or radius with 1, and its volume already we know the volume of sphere v will be equal to 4 by 3 pi 1 square because 1 is radius, and that will be 4 by 3 pi. So let's put this value. You will get the value of given integral, that is xi bar plus byj bar plus czk bar over surface S will be equal to a plus b plus c into v, that is a plus b plus c into 4 by 3 into pi, or that will be 4 by 3 pi a plus b plus c. So this will be the resulting value of this surface integral. So yeah, so I will give two examples as homework. Already I have shared the PDF of this notes in WhatsApp group as well as Google Classroom, so you can refer these notes and you can solve these two examples as homework. So this is about Gauss divergence theorem and examples on it. So I will stop here.